So the first thing is, what is data? So when you consider a data structure is a combination of two words, data and structure. So what does mean by a data? Anyone can tell me what does mean by the data? Data refers what? So from the data structure, the first word data and structure. What does mean by a data?
Information, sir.
Information. Like let's say Balu sir sessions are started today, 7 o'clock. This is one information. Or you can say students are paid 5,000 amount for the data structure. This is one piece of information, right? So in real world, any piece of information, if you are going to represent, that is going to call as a data. Any small amount of information, any piece of the information, if you are representing, that is going to call as a data. So data is nothing but any piece of information is called data. It can be anything. Maybe you will say, I joined the session. Maybe you say, we are going to join the session. You say, I paid the amount. You can say, I was registered the course. Any piece of the information is going to call as a data. Okay, so what is data? Any piece of information is called data, right? It always in the form of characters. So if you are going to say data structures by Balu, so that is piece of the information. So it always in the form of characters, that is binary information, also character type data. So any data, if you are going to represent, that particular data always in the form of characters. So any piece of information is called data. It always in the form of characters, that is binary information also is character type only. So why I am going to say it always in the form of character means, if consider a binary representation, binary representation will come in the form of ones and zeros. So when the binary representation will comes in the form of ones and zeros, that is also treated like a data only. So any piece of information is called data. Any data is going to represent in the form of characters, even though the binary data also we are going to call as a characters. Okay, that. So what is data structure? So previously we discussed what is data. Any piece of information is going to call as a data. Then what does mean by the data structure? So what does mean by the data structure? Data structure represents what? So data means any piece of information. Then what does mean by the data structure?
Way of storing the information.
Way of storing the information. Listen, so whenever you are going to represent certain kind of data, that particular data has follows some structure. So that particular data will follow some structure. Like if you are going to represent some books in your shelf, if you are going to represent a books in shelf, it follows some kind of order, right? So representing the books in the shelf is one particular order it will follows. Even though if you are going to, if you have a multiple coins, so placing that one by one coins top of another coin, that is also one kind of structure, right? Even though iron cloths, if you are going to store your iron cloths in the cupboard, or if you are going to store your iron cloths in the almari, that is also one kind of data structure. So any kind of information, when you are going to store in the computer memory, that particular data has follows some kind of order or some kind of structure, that is going to call as a data structure. So data structure is always talks about the representation. How you are going to represent your data in the memory is all about the data structure. First point, data structure is not a programming language. Okay, data structure is not a programming language. Data structure is not about the programming, and data structure is not about the C or C++ or something. Data structure is about the representation of the memory in the computer. It can be applied to C, it can be applied to C++, it can be applied to Java, it can be applied to .NET, it can be applied to entire software world. Okay, So data structure is not a programming language. Data structure is a kind of data representation in the computer. So when you say data representation in the computer, it's not limited to C or C++. It's not limited to any programming. It's all about the computer software engineering. So in software engineering or in any kind of technologies, they are going to store the data. So the data storing concept itself is a data structure. So data structure is not a programming language. Data structure is not belongs to C or C++. Data structure are applicable to entire software world. For any programming languages or any kind of technologies, data structures are exist. Maybe the syntactically, I'm going to write the code in C, you are going to write in code in C++, or you are going to write the code in Java. So data structure is not a programming language. Data structure is something about the representation of the memory, and it is applicable to entire software technologies, entire programming language, in everywhere in the software data structures will come. Okay, so a data structure is a specialized format for organizing, processing, retrieving, and storing the data. That means information. So a data structure is a specialized format for organizing, processing, retrieving, and storing the information. That means a piece of information, if you are going to store in the memory, a piece of information, if you are going to retrieve from the memory, a piece of information, if you are going to manipulate in the memory, is all about the data structure. So data structure is not a programming language. Data structure is something about the representation of the data, which is can be applied to across the software technology. It's not related to C or C++ something. Okay. Then in computer science, a data structure is a data organization management. In computer science, a data structure is a data organization management and storage format that enables efficient access and modification. So whenever you are going to consider a data storage, so whenever you are going to store any information in the computer, it has to be organized in a particular manner, and it has to be give a best time complexity. It has to be give a efficient access and modifications. These are all about related to time complexity of the data, how you are going to represent. Then it always talks about logical related data. So whatever the data you are going to represent in the memory, that particular data are going to manage some kind of logical relationship. So whatever the data you are going to organize, that particular data is going to manage some kind of logical relationship. Okay, in data structure, any kind of operations must be performed between logical oriented data elements. That means if you are going to insert, if you are going to delete, if you are going to search, if you are going to travel, so any kind of operations if you are going to perform, those operations must be performed between logical oriented data elements only. This is all about the data structure. So only 2 points we discussed. One is data, one is called data structure. So data means any piece of information we are going to call as a data. Okay, data structure means it is all about the representation of the data in the memory. So when you are going to represent the data in the memory, it is applicable to across all software technologies. It's not specific to C or it is not specific to any languages. And important point is that data structure is not a programming language. It is all about the data representations. So whenever you are going to represent the data, you have to consider 2 points. One is how efficiently my data is storing and what is the time complexity of that particular data in order to modify or in order to retrieve. Okay, so data structure always talks about something logical related data elements, and all operations has to be carried forward with some logical representation. Okay, sure. Let's see some kind of real-time applications of data structures. So how many people are going to use call centers? Let's say you got a problem in your prepaid services. You are going to call to call center like Vodafone or Airtel or BSNL, whatever. Okay, or you are going to call a banking transaction. You are going to call. Imagine. So when they are going to run a organization of a call center, they are gonna follow data structures only. So how they are going to follow the data structures? Like say I was called at 7 o'clock and you called at 7:10. Who's gonna serve first? Let's say we both are calling together to Vodafone customer care services. When we are calling to Vodafone customer care services, what is gonna happen? So who called first, those people will respond first. Who called later, those are going to respond later. This is one kind of real-time application. So this is one real-time application of a data structure. Ever wondered how your calls are managed when you call a call center or customer care? So if you are going to call a customer care or if you are going to call a call center, they are going to follow a data structure order. What is that order? Anyone knows?
Queue, first
Queue,
come first.
first come, first serve, FIFO
Yeah.
order. Queues we are
Yeah.
going to use. So that call center mechanism, that means the call receiver software. So in call center, whatever the call receiver software is there, that call receiver software is implemented based on the queues. Okay, so who is going to call first? They are going to place in the queue first, and whenever one agent is free, is going to pull that particular call. So in which order customers are entered, in the same order it will serve. That is going to call as a call center management or the customer care services. These customer care services are going to manage based on the queue, first in, first out, FIFO order, or first in, first serve. How many people are using Facebooks?
Lots of
Everyone has
stuff.
a Facebook account, right?
Yes, sir.
So in Facebook, whenever you are going to send a request to your friend, okay, whenever you are going to send a request to your friend, if your friend is accepted a request, then that friend related friend list are automatic suggestion to your friend list. Anyone observe this one? Whenever you send a friend request to a friend, and if that particular friend is accepted your friend request, then that friend related all friend lists are automatically suggestion to your friend list. Let's say you are friend to me, then what is going to happen? You will get all the list of suggestions automatically. Those people are friend in my list. You observe this kind of things?
Yes.
No, no, it's a general. Even though you open your contact list, so first list will give you that list of requested which you got, and the next in the bottom you will see all the suggestions, and you can see two mutual friends, one mutual friend, three mutual friend, four mutual friends, because it follows one kind of algorithm there. It can one kind of data structures it is going to follow. So for the call centers, so due queue data structure is the answer. The caller who calls first gets the priority on answer for first come first serve. That is for call center. And the next one is for the, this is one something about the IDE like compiler. So if you are using a compiler, how does an IDE or compiler works on the missing braces? You remember when you open the body, curly braces. Whenever you are going to open the body, curly braces. If you open the curly brace, it required a closing curly brace, right? If you forget the closing curly brace, then compiler will give the error actually. Okay, so
Yes.
if you are opening the curly brace, then compiler has to give the closing curly brace. If you miss the closing curly brace, you will get error actually. How this compiler knows this one based on what? Based on which
Mm,
particular structure it is going to handle this one means based on the stack. So based on the stack, my compiler will understand that either opening curly brace has the closing or not. So call center will work on the queue structure, whereas the IDE or the compiler is going to work on the stack structure. Okay, then wonder how you get friends suggestion on the Facebook, how are your friends or non-friends identified? So how your friends list friends are identified to you. This is gonna work on the graphs. So it works on the graph actually. So graphs are having two type of things, right? Connected, okay, connected graphs, unconnected graphs. These are gonna work. Graph can solve this issue. Each node represents a user and every link between them can represent a connection. Let's say from my account to your account, there is a link that is connected. Then what will happen from my particular order, it will check that which are connected to you, but which is not connected to me. Okay, so this is gonna work on a basic structure like that. Okay, now observe here. This is a user one, it is me. Okay, and here is one guy, Anish. He's now here, and this guy has two friends. Let's say some like this and like this. Okay, so this guy B has, so A has two friends. So when B sending the request to A, okay, A is responded to B, then what will happen now? The B will identify, so there are these two people possible to connect because B and BA was connected and A or SA was connected. So these two people are not connected. So you will get a request or you will get a suggestion from these two people because these two people are not connected. This is a graph structure which is used by the Facebook. So in the Facebook connection list, graph structures are there, and those graph structure algorithms they are going to use basically to identify who is a non-friend of a friend or who is the suggestion of that particular friends list. These are all about the real-time applications itself. So even though redo operation, so if you are going to say Control Z, redo operation also going to work on the real-time application. Like lots of scenarios are there where the real-time applications will there. I given some useful examples. Call centers are there, IDE is there, Facebook graph APIs are there, and the redo, these all are going to work based on what? Data structures also. For example, do you know how the DOM in the sense document object model. So document object model means mm, you have computers, right? If you go to C drive, if you go to the program files, if you go to the next level, next level, next level, like whenever you are going to work on a file and that file has a nested, right? So go to the D drive, go to your photos, go to your album, go to your photo again. So if you are going to open the nested layers, it has some object model. Those also goes work. Those also will work with the help of this. So in your system, the file systems are there, right? The file system path is going to manage by using tree data structures. So these are some kind of real-time data structures actually, which are going to use everywhere. Like file system, directories, these are going to work on the hash tables. Okay. So if you consider your real-time application, basically the people will ask that if you go to the Facebook actually, if you are attending the Facebook interview, they will say you that, okay, how the friends list is going to manage, what kind of data structures are going to manage by the friend list. So that is going to work based on the graph. How a call center management is going to work. If you have an idea, explain them. Okay, how the ID is going to identify that, how the closing curly brace is missing. Okay, so these kind of straightforward questions actually. So whenever you are going to attend the top companies, any companies like Google, Amazon, Facebook, right? A top MN6 companies, if you are going to attend, the elimination round itself is a C programming along with the data structure. The elimination round itself is a C programming with the data structure. So you should know the data structures properly in order to get the jobs. In order to get the jobs, you should know the data structures properly actually. So if they are going to ask you that, okay, how this is going to work, how this is going to work. Just you have to analyze that, okay, this is a data which is going to represent by using this format. This is a specific data structures are going to use. Okay, few real-time applications of data structures if you consider compiler design. So if you are going to work on a compiler design, especially embedded softwares, okay, those are going to work on the embedded engineering. Those people are going to work on this one, compiler designing, stack memory allocation. This is completely on the data structure. Operating system like memory management is going to work on the linked list and hash maps. That is also real-time application. Database management system is going to use B-tree, like you are going to work on Oracle, you are going to work on SQL Server, you are going to work on the big data, you are going to work on the big queries. These all are going to represent based on the B-tree. So compiler design going to use a stack memory. Operating system is going to use linked list and hash maps, whereas a database management system is going to use B-tree. File system representations are going to use tree. Like these all are network data models are going to use graphs. So this is a real-time applications where you can see your data structures in the real-time picture. So compiler designing will take care, stack memory allocations will be take care based on the data structure. Operating systems like memory management going to use a linked list and hash maps. Database management system is going to use the B trees. File system representation of the operating system going to use a trees concept, and the data model are going to represent the graph. These are the real-time applications which everywhere the data structure exists. For example, a Java developer is going to work with the Oracle backend. So Oracle backend is going to work with the help of data structure itself. It's use a B plus tree actually. Okay, so these are the real-time applications. Okay. Then if you consider the type of the data structures, there are only two type of data structures are there. One is called linear data structure. Examples of array, list, stack, and queues. Linear data structures, arrays, lists, stacks, and queues, whereas the non-linear data structures are trees and graphs. Okay, types of data structures if you are going to consider, there are only two types of data structures are there, linear data structures and non-linear data structures. Linear data structures are going to call array, list, stacks, and queues. Non-linear data structure is going to call as a trees and graphs. Okay, then linear data structure. So what does mean by the linear format in the sense what? What does mean by the linear format? Subhashish,
Sequence,
sorry.
sequential way of sequential data means data is stored sequentially.
See, actually there are like some kind of, conflicts will be there in the linear word. Linear in the sense one-to-one relation. Okay, that's it. Simple stuff. So people will say sequential. Sequence means we can't say 100% is a sequence. It is one-to-one relation. That's it. One object has a relation with another object, or one element has a relation with another element. That is called sequence. Because when the people will say linear, and if you are going to refer a sequence word, the people will think, okay, continuous memory block. Got my point, what I'm saying? So whenever you are going to say linear data structure, try to eliminate the sequence, because if you are going to follow the word called sequence, the problem with that one, the people will think sequence in the sense they need a continuous memory block. Got my point? So continuous memory block will not exist every time in the linear data structure. Okay, only array if you consider the continuous block of the memory will be there. But stacks and queues and linked list if you consider, there is no sequential memory. So try to eliminate or try to avoid the using sequential representation. Okay, what you have to say actually, linear data structure means the data elements are going to store in sequence. Data elements are going to store in sequence. Don't talk anything about the memory here. Okay, don't tell anything related to the memory. You can say the data elements are going to represent in the sequence one-to-one relation. So one particular element has a relation with another element. That's it. You can't refer always the sequential memory will be there. Okay, so linear data structure means in linear data structure, all the elements are stored in sequential order. Sequential order is not refers the sequential memory. Okay, so this point is very important to understand here. So in linear data structure, all the data elements are stored in sequential order. Sequential order is entirely different from sequential memory. Sequential memory in the sense continuous block of the memory has to be generated. So except the array, in the rest of any kind of linear data structure, sequential memory block will not generate it. Okay, sequential memory block will not generated in any other data structure. So trust this particular point here. In linear data structure, all the data elements are stored in sequential order. Sequential order is not same as sequential memory representation. Sequential order is not same as sequential memory representation. Both are different. In linear data structure, the adjacent elements are attached to each other. Like one element will have direct relation with another element, one-to-one relationship. In a linear data structure, the adjacent elements are attached to each other, not in a continuous block of the memory. So linear data structure doesn't tells you that always it represents in the continuous block of the memory. There is no any condition is there. Always you need a memory in the continuation block. Okay. However, these data structures do not make better utilization of the memory. Therefore, it can lead the memory wastage also. So whenever you are going to work with the linear data structure, so linear data structures represent in the sequential manner, that is one-to-one relationship. One element has a relation with another element. Maybe continuous block, may not be continuous block. But the problem is that linear data structures are going to occupy the more memory. Linear data structures are going to occupy the more memory. So when it is going to occupy the more memory, it can lead memory wastage also. This is all about the linear data structure. And the non-linear data structure means, so non-linear data structure means those are going to represent in the form of hierarchical. So in non-linear data structure, elements are stored in non-sequential manner. Okay, in non-linear data structure, elements are stored in non-sequential manner. That is, it forms a hierarchical relationship. Okay, it forms a hierarchical relationship. Then, usually these data structures are more memory efficient. Okay, so usually these data structures are more memory efficient. So I'm not giving any example. We will discuss those things later on the next sessions itself or next topic actually. Okay, so conclusion of this particular things right now. What is data? What is data structure? What are the real-time applications of the data structures? What type of data structures are there? So data means any piece of information is going to call as a data. Structure means the representation of the memory. The data structure is always tells about the representation of the memory. Okay. In the real-time applications of the data structures, if you consider, call center management will be there, right? Facebook graph APIs like friends list APIs are there, IDEs are there, and what is next? Like compiler designs are there, database management is there, networking systems also. These all are comes under the data structure. So data structure is a programming language. Data structure is something about the data representation. And data structures are classified into two types. One is called linear, one is called non-linear. Linear data structure means elements are going to represent in the sequential order. Sequential order is not same as sequential memory. Sequential memory is not defined in the linear order. Non-linear in the sense hierarchical representation will be there. Time complexity purpose or the memory concepts, memory purpose, non-linear data structure gives better performance than linear data structure. So linear data structure can lead the memory wastage, whereas a non-linear data structure will not gonna waste. Okay, these all about data structure, types of data structures and applications. And the next one, we'll discuss about pointers, we will discuss about arrays, and we are going to do some kind of coding. Why pointer array structures are required? Why these topics are required for us? Because in order to implement a data structure like linked list if you consider, or stacks if you consider, or queue if you consider, linked list, stacks, queues, if these three things if you are going to consider, we should know about the fundamental things of pointer array structures. Okay, so before moving to the data structure, briefly we will check these things with some kind of codes, and we will check these things how these are going to implement it. Okay.